Chapter 2 assessment. So I'm going to be building a function with the equation 6x to the 5th plus 2x cubed minus 8x. So what I did was input negative 1.25 into the equation to give me negative 12.2 as an output. As you can see on the graph, which was based on the equation that negative 1.25 equals negative 12.2 plus, and you can do with all these numbers, you can put input into the equation, you will get these outputs. Now, as you can see on the graph, what it looks like is it's going up, then down, and then back up. If you take a closer look at it in the graph, you can see it, but not quite unless you put the line in. You can clearly see that it's going up, down, and up, which you can see again as it's zoomed in. The domain and range are all real numbers. The local max and the local min. The max is negative 0.653 and 3.95. The local max point is 0.65, negative 3955. As you can see, it's just the negative and positive sign are just being switched by the two numbers for their local max and min. The increase is negative infinity to negative 0.653, union 0.653 to infinity. Decreasing is from negative 0.653 to 0.653. Now, next is part 2, the piecewise function. I chose f of x equals to like x. It's x plus 5. If it was negative 6 is less than x but greater than negative 2. I plugged in negative 5, which would then into the for x, which would mean we have to use this equation. So putting negative 5 squared plus 5 equals 25 plus 5 equals 30. I did the same thing for each of the three functions to get 30, 8, and 6. As you can see in the graph, negative 5, negative 2, and negative 3. Negative 5 is 30, negative 2 is 8, and 3 is 6, just like the answers I had gotten on the previous slide. The domain is negative 6 to 5. As you can see, well, you can't see on the graph here, but this line continues on just to negative 6, and this line ends at negative 5, giving the domain of negative 6 to the 5th. While the range is 2 to negative 6, again, you can't see it. Oh, actually, I'm sorry, it shouldn't be negative. Yeah, okay. There is no local max and local min because none of the points are being connected. Whoops. The increasing is 2 to the 5th, or sorry, 2 to the 5th, as in this blue line. The decreasing is negative 6 to negative 2, as in the orange line. Again, you can't see the negative 6, but this line on top ends at negative 6, but it is negative 6 is not part of it because it is undefined. Transformation from parent function. I chose parent 1 as x squared and the second parent as the square root of x. These are the parent functions. Now I did a vertical for the first one. I did a vertical shift by 3. So all it did was take the original parent functions, which these dotted lines are the parent functions, and just move them up by 3, as you can see over here and over here. Then I did a vertical shift downwards, which is just like the previous slide, but instead of going up by 2, it's going down by 2, meaning the equation would then be x squared minus 2. Like the previous one, since it was going up 3, it was a plus 3. Now, I did a vertical shrink by a factor of 2, meaning making the x squared, f of x equals x squared into f of x equals 2x squared. And then, as you can see, this line is the parent function as well as this, while this and this are the vertical stretch. And the vertical shrink, I did a factor by 4, meaning since it's a shrink, I had to add 1/4 instead of just a 4, meaning making the equation be 1/4 x squared, and this would be the parent function, and this would be the new function, the 1/4 x squared. This same thing here, this is the parent function, and this is the 1/4 with the square root of x. Then I did a horizontal stretch by a factor of 3. I put the 1/3 x in parentheses, then put the squared. It's basically the same thing as this, but this time it's just in parentheses, which then had done, this is the parent function, and this had increased by 3, stretched out horizontally. This is the square root of 1/3 x, which here's the parent function. It just had brought it down by basically by 1/3. And I did a horizontal shrink by a factor of 4, which is just shrunk down the parent function by sorry, I meant I did a vertical shrink by 5, not 4. This says 4, but it was actually 5. So shrunk the equation by 5. This one also, but instead of shrinking it, this increased it by square root of 5x. Combining functions and graphing addictions. So I chose the two functions f of x equals 1/4 x squared and g of x equals 1/2 x minus 1. So the f of x equation is being graphed with the color red, as you can see in the graph. The g of x is being using black. As you can see on the chart over here, if you input, you will get an output, just like on the graph, like a -4 for x, for f of x would be 4. You can't see it, but this is a 4, and there is a point there. And then for the same thing for -4 for g of x, it would be -3 because it's landing on the -3. Now, if you look at -4 for both f of x and 3, if you by doing f of x plus g of x, you're taking 1/4 x squared plus plus 1/2 x minus 1, and you're plugging in -4 for the x, which would give you 1, as you can, which would do. Now, if you look at 4, you're taking the same, you're doing the same thing, but this time you're plugging it in with 4, which technically would give you for the f of x, which would give you 4, and for the g of x, it would give you 1. So if you just add them together, because it's f of x plus g of x, it would give you 5. Now, if you take f of x and f of x plus g of x and you put it on the graph, it will you can see it. You can't right now. It's just you can barely see, you can see it, but you can't tell. It's because of the green dots without the line. But if you look at the next graph, you can see the green line that's going. That's the f of x plus g of x. 1-to-1 inverses. So I chose the function 1/3 x cubed plus 3. Now this is the graph that goes with the function. To find the inverse, I took f of x and turned it into y. Then I subtracted 3 to get y minus 3 equals 1/3 x cubed. Then I times the entire thing by 3 to get rid of the 1/3. That would give me 3y minus 9 equals x cubed. Then I cube root the entire equation to get x by itself, which would give me the cube root of 3y minus 9. So then what I've done was switch the x and y to get the f of -1x, the inverse of the original equation, which would be the cube root of 3x minus 9. As you can see in the graph, the blue line, that is the inverse of the original equation. The blue line is the cube root of 3x minus 9. Now, it is a 1-to-1 equation because it passes the line test, where if you have a line that goes this way, there's only one point that touches with it. And then if you put as you can see, if you put the f of y equals x line, you can see that it's a reflection over the y equals x line, which the y equals x line is the green dotted line. Now this is an example of not one-to-one equation. I chose the equation 4 parentheses x minus 3 parentheses to the fourth root minus 3. And then this was the original graph that you get, but because it doesn't pass that line test, where if you draw a line through 2 for y, you can see it passes through 2 points, 2, 2 and 2, 4, 2. So I had to restrict the domain, which would be x. It has to be greater than and equal to 3, which would basically just take out this line, which would right is as shown as the dotted line. That's the original line that which was this, but now because we've restricted the domain, that has been taken out. Which now it would, if just pretend the dotted line isn't there, and if you drew a line at 3, it would pass the test, which would be 4, 3. Like in the previous line, it wouldn't pass because there was also a point at 2, 3 and a 4, 3. This time it's just at 4, 3. So now you're going to take the restricted domain equation and find the inverse. So why I did it's just like the previous ones, where you take the f of x turn into y. By doing each step, you would then get the to get the fourth root out, you'll get plus or minus the fourth square root, but it has to be greater than or equal to x has to be greater than or equal to 3, meaning you cannot use the plus sign, leaving you with this should be just 3. You shouldn't need to have the plus or minus, because all you're going to need is f of x minus 1 to the square root of x equals 3 to the fourth the square root of 4 with x plus 3 over 4, which would give you the function. This is how the graph would look like. It is kind of a reflection over the the y of x action. Y equals x, the line, which is the green dotted line. The domain of the original, original function that had the restricted part, the domain would be 3, which was included to infinity, while the range would be -3 to infinity. The domain to the new function, the inverse of this function, would be -3 to infinity, and the range would be 0, as you can 0 to infinity.